And welcome to Ditch Diggers Dialogue Volume 10. For those who don't know me, my name is Ashley Hudson. I'm the Operations Manager for the Heavy Construction Contractors Association. HCCA strives to provide educational and networking opportunities for our membership, so we created the Ditch Diggers Dialogue series as a virtual way to stay connected. For today's session, you will hear from Stephen Carter, COO and co-founder of TRAXyL. Stephen is passionate about his work at TRAXyL, where they are turning roads into digital highways to close the digital divide and enable global connectivity. HCCA met Stephen and TRAXyL in 2018, and we are excited to see their innovative technology expanding to other states. We hope you will enjoy the presentation. During today's session, we ask that you keep your microphones muted until we open the floor for questions. Please type any questions or thoughts in the chat box as we go along, and we'll discuss at the end, and I think we'll have a break in the middle as well to discuss questions throughout the presentation. So now I will turn it over to Stephen and let Stephen further self-introduce if you would like. And Stephen, thank you for being here, and the floor is yours.
Thank you very much, Ashley, and for the Heavy Construction Contractors Association. It's very nice to be invited here to talk a little bit about what we do. We're not super heavy construction, but we play a role and touch a little bit of a lot of what your members get involved in the industry every day. So hopefully we can find some meaningful, share some meaningful information here, and hopefully somebody finds it a little bit interesting. So thank you very much, really appreciate it. Again, I am Stephen Carter, co-founder of TRAXyL, and we're a startup based in Virginia. So we are actually moving offices into the Gainesville area. So if anybody's around, we'd love to say hello to you and let us know. And yes, it does seem like a small enough group that I'd love to keep this interactive. If anybody does have Q&A during the time, I probably won't be able to see it in the chat. Maybe Ashley will monitor that, but please feel free to interrupt and ask questions at any time. So I'm sharing my screen now, and I will get this situated. So thank you again, really appreciate it. And our company is TRAXyL. We are a startup that is growing in what we're trying to do, and that's really try to get broadband to everyone. It's about internet and connectivity, and even beyond internet, a lot of different things that you can do with the technology that we've developed. So, and what we really think is really important are things around access to information, access to knowledge, and really a lot of that comes through the access to broadband internet connectivity. There's a lot of different technologies that play a role in it, from 5G to the infrastructure, the cabling, to other wireless and telecommunications devices that play a role in getting that information, whether it's data collection or actually getting services to the home or business. And even with things like wireless or even the nation as a whole, it runs on an optical fiber network. And so fiber optic is critical to getting connectivity around the different areas. And we have a nationwide backbone that runs on fiber, but there's a challenge in the last mile, which is actually getting connectivity to the home. And that's getting fiber, which is the preferred method for communications in those hard to reach areas. And a lot of times that's the last mile, which is the most expensive portion of the network. And it becomes expensive because the closer you get to those endpoints, the more utilities are underground and already in those locations, like your water, sewer, electrical, gas, different things like that. And so what a lot of heavy contractors do is they trench the grounds, or they cut into the surfaces, or there's paved surfaces that have to be cut into, and the property has to be restored after the cables have been installed. So it can be a very time-consuming process. It can be pretty expensive, and it can be damaging to the underground utilities, to the rights of ways, whatever it might be, the environment, and even the flow of traffic and everyday life. So those are the types of things that we're trying to avoid. And so we developed FiberTRAX. And so we're essentially painting optical fiber onto hard surfaces or paved surfaces to bring data connectivity and broadband into hard to reach areas. And so the pathway, like the hardscape surfaces, like your asphalt and roads and sidewalks and everything else, that was typically the most challenging portion of a network to install, because there are a lot of underground utilities, and when you cut into the road, you really don't know what you're going to get. And you can survey and do different techniques to understand what's there, but a lot of surprises happen once we cut into the road. So we're really trying to make it simple and easy for installers and contractors to install cable. And we're trying to get another tool in the tool bag for the contractors and installers so that when they go out to do installations, they can use this as another method, another technique. And we think about it as an on-demand solution for fiber installation, where you're not cutting into the road surface, you're not having to underground locate to understand where all of the utilities are, but really you're coming out and you're painting a stripe onto the road that blends into the road, but the profile is pretty low, and you don't have to worry about what's underground, and you can just drive it across, almost like painting onto the road network. So you can think about using the road network as a pathway instead of a challenge. And so we say paint, but we're not actually painting. You can imagine we're using very low profile cables, and we're using very durable protective coatings. So we have a low profile cable that has 12 fibers inside. We have it wrapped in steel armor and Kevlar, and it's got an outer jacket to kind of conceal everything together. And then it's adhered to the road instantly using our bond coat, which is kind of that grayish color that you see here. And then we have a top coat that we use that gives it a little bit more durability and protection. And the idea, again, is that it's a very low profile. So it looks like a paint line on the road, but it blends into the surface. And you could probably think about it too, if you're familiar with thermoplastic or crosswalk intersections or heavy traffic areas where it's a slightly raised paint line off of the road surface. It's not super flush, but it's slightly raised up, and that's about the thickness that we're working with here. It's ramped on both sides, so it's ADA compliant. It's even below the threshold for ADA. We put it in roads, put it in parking lots, sidewalks, bike paths, anywhere there's a paved surface that you want to get connectivity, you can use FiberTRAX. And some of the other methods, the conventional methods that we're used to, would be drilling, horizontal directional drill, boring, micro trenching, using utility poles or deep trenching even. And utility poles, they're not everywhere, and they're probably one of the least favored methods because of aesthetics and vulnerability. But we think about this as a complementary method, again, where it's not a silver bullet solution. It's nothing that's going to replace every type of method. We know that there's always going to be a need for trenching or micro trenching and hanging on utility poles. But the idea is, can we provide a technique that alleviates some of the challenges that these other ones pose? And even wireless, a lot of people think about a wireless solution as doesn't need cables, but it does transmit a wireless signal to your device, your handhelds and your wireless devices. But a lot of that technology depends on fiber backhauling that data to the middle mile or backhaul network. And so even something like 5G, which is something that we think is going to be a very big market, is that it's going to need, it's going to need 10 to 15 new 5G antennas for every existing 4G antenna. So while it does have a faster signal and you can run more data through it, it doesn't cover as big of an area. So they're going to need more of them, and each one of them will require 6 fibers to backhaul all of that data. So really, we just want to be another player in the market. We want to be another technique, another, again, what we call a tool in the tool bag for the installers and the network architects to choose as they start to design and build out an infrastructure network. And this is a little bit of a notional schedule for FiberTRAX versus some of those conventional methods. And while it can vary greatly from region to region, there's very few places that we've come in contact with that say that this is too unrealistic to put a mile of fiber in the ground. You could think about it, wherever you are sitting today, if you wanted to start trenching and installing a mile of cable from wherever you are today, all of the different challenges that you would run into from jurisdictions and approving authorities and permitting, and then you actually got to start the construction and you've got to excavate and you've got to shut down lanes of traffic and you have to get right of ways and everything else that goes into that. how long and how many times we pass that same spool of cable and that same piece of trenching equipment sitting on the side of the road, building out the same network for weeks and months on end. That's the type of schedule that we want to compress, where we know that there's going to be design and permitting, but the process is so reduced because you're not actually impacting the road in a way that a conventional method does. You're not potentially cutting up existing lines or damaging gas pipes or water mains. And so that process is expedited quite a bit. And you still want to implement your junction boxes wherever they would go and design your network in the way that you have expansion capabilities. But we do get to avoid the excavation and the backfill and the restoration of those surfaces, which in a lot of cases, we've heard it can outweigh the actual cost of putting cable into the ground. If you have to go back and restore and backfill it, that portion alone can be so detrimental to a job that it doesn't even go forward. And then you still have terminations that get connected. And that's the beauty of what we're doing, is that the fiber install portion can happen rapidly. I mean, we're talking about thousands of feet a day. Our machine that we're working with, we have a couple of them, and I'll show you a kind of a progression of what we've done. But the current machine is going about 1,000 feet an hour. So you can think about how much cable you can actually lay in a day with multiple crews or strategically positioned and running optimally. So it's a very rapid, on-demand, safer method for installing cable. And the terminations are all the same. And everything that we're working with is very industry standard. So you've got cable that is optical fiber industry standard SMF 28 from any, or really I say SMF because that's what we use most frequently, but we can insert really any type of fiber that you want, whether it's multi-mode or single mode. And the fiber is all industry standard. The junction points are industry standard. The splices, the connectors, whatever it may be, is all industry standard. And so there's nothing too unique. Some of the transitions, how you make transitions from roads into grass areas or roads into through curbs or different elevation changes. There are transitions that we've had to overcome and design for, but we haven't come across any that we haven't been able to design to, including vertical surfaces like going to a building or going to a utility pole. So we can really think about bringing down the time for installation, getting it into hard to reach areas, which could be rural, non-urban and urban areas, or it could be on bases or different areas where there's a dense community trying to get connectivity. So we think about ourselves as a technology company where we are developing these tools, these equipment, these processes, the materials that are going to go into what is FiberTRAX and how it's being distributed and installed. And we've been able to go out and do installations ourselves in various locations and at different times. And the idea really is that we want to, again, be a technology company who is helping the installer. We don't necessarily want to go out and compete for the other business, but we want to be a solution provider where we're building the equipment, we're leasing it to the different contractors or municipalities or internet service providers that need it. And then we're training them and getting them certified on operating the equipment and installing FiberTRAX, and then continuing to sell the fiber, the coatings, and other ancillary kind of tools and equipment that go with it. And that's, we think about it like a printer ink model, where we're giving you a printer to go and 3D print almost a fiber cable onto the road. And then we're going to continue to sell the protective coatings and provide the technical support. So we're reaching different customers, which again could be a cable installer, an ISP, an internet service provider, a municipality, a military base, a school campus, a residential community. There's all sorts of places that when you start thinking about where you could install FiberTRAX rapidly and on demand, that you could that you could see the benefits and end users that could benefit from it. And so those are some of the places that we're looking. Again, we're looking at last mile connectivity. We're not trying to run between DC and Philadelphia. We're trying to get all those areas in between. those major cities and even a lot of the middle market cities and a lot of the small cities have fiber that run right through them. They just get bypassed because the return on investment wasn't enough for an installer to go and branch out into all the different areas. And so we're trying to target that last mile network, which is traditionally 13 times more expensive than the middle and long haul networks. And so we're trying to reach the communities that have been kind of on the fringe of getting high-speed internet and fiber, a robust fiber network in their community. We're targeting different bases, airports, campuses, office parks, schools, those types of places. And we're working with different channel partners and distributors to reach those customers because they know that industry best. They've already got people who are having this same type of challenge of getting connectivity. And so, you know, that's really our market and what we're trying to, and who we're trying to reach. So Ashley, I will pause there for just a moment to see if there's any questions in the chat, anything that you might have already seen, but and then I'll get into a few use cases of of some of the FiberTRAX that we've installed. Do we have anything yet?
I don't see any questions in the chat box, but if anyone has a question so far, feel free to unmute.
Great, thank you. And Ashley, if I could just quickly ask.
Got a quick question.
Yeah, go ahead.
Hello. Yeah, I'm sorry. Hey, I may have missed it. What is the largest size fiber that you guys are deploying under this right now or with this?
Sure. So currently we're installing a 12 count fiber. We've got pathways in our R&D effort to try to get to 24, and we think we'll be able to get to 24 by the end of this year or sooner. And we have also, you know, if you want to try to get fiber to a location, you can run it on multiple sides of the road to get, you know, to double the count that you're installing under each stripe. So if we've got 12, you can, you know, run 2 passes and get 24. If we get to 24, you can run 2 passes to get to 48. And we recently did an installation for the Ohio in Ohio on a Department of Transportation bridge, where we did a bit more of a unique and custom installation, and we actually put 96 fibers across the bridge. So we had a little bit larger cable and a more custom machine, but it was a 24 count fiber cable, 2 cables under each stripe, and a stripe on each side of the bridge. So 24 by 4 to get to 96.
Okay. Okay, good, thanks.
Absolutely. And actually, if I could ask you to forward that meeting link to Dan Turner, that would be great. He may be able to do a cameo live from Vicksburg, but he's still trying to work that out with them.
Awesome, okay.
Thank you. Yeah, so this is an installation where we worked with an ISP and they got approval from the Homeowners Association. They basically put a project out to bid. They wanted fiber into this community. It's in Greenville, South Carolina. This is pre-COVID, where the ISP had a 5-year contract. They said they would get the project built out in a certain amount of time and start servicing these customers pretty rapidly. And towards the end of their project, they still didn't have a solution for getting across the paved surfaces. So there's 36 apartment communities, apartments in this community, or 36 apartment buildings in this community. And it's got a bit of a circular pathway for the cars to travel through the parking lots. And we came out, we surveyed, they had water and gas under the parking lot, and they didn't want to trench or drill under the parking lot because of the risk. And their contractors were pricing in that risk, and it busted their budget. They also couldn't meet it in the time frame that they needed it. And so we had met them at a trade show before. They called us from Greenville, and they said, "Are you going to be able to do this? We'd like it done as soon as possible." And so we did a remote survey where we worked with Google Earth type imaging, and they took some photos. We drove down and we installed 4 different links for them in the same day. They connected their fibers the next day, and that following Monday, they were able to turn on their customers and start bringing service to this community. So knowing that this was pre-COVID, this community was pretty happy to have fiber while their children were learning from home, and a lot of people were doing telework. So this was a really good project. That they have a 5-year agreement. We have a 5-year agreement with the contractor, but it's something that we did ourselves. And we're using a garage-built prototype equipment, and it's very prototypey. If you look close enough, you'll find some zip ties and C clamps still on here, but this is a machine that we built ourselves, and when it actually ran 2 passes. So the cutaway that I showed earlier, there was a bond coat and a top coat, and this first pass that you see coming at you in the image, it actually runs across a tar line. So this big black line that runs out of screen and across the screen is a tar line. But we ran this first pass down, and that's what it looks like with the fiber and the first pass installed. And then it's a little harder to see, but there is a very light, faint black line that runs across the tar line into the parking spaces and up to this curb area where our top pass has been completed. So this garage built custom piece of equipment was a 2-pass system, not as efficient as our current one, but it definitely was able to get the job done. And what you can't see behind this image is a junction box that sits in that grass. So we were actually able to transition through the curb onto the sidewalk and actually have a strip of FiberTRAX onto the sidewalk, and then we transition into a handhole in the grass. So I'll be able to show an image of that in a few minutes too. This is another installation, a little better view of our garage built prototype, and it's being done at Dulles Airport, right outside DC here in Virginia, where a car rental facility acquired another building. You can actually see it on the picture on the right behind this car. There's a building that's lit up in the back. They acquired that building. They wanted the 2 facilities connected. And once again, it was the contractor was coming up to the deadline. You can imagine all the utilities that are underground at this airport, and airport authorities are notorious for being very particular in what goes into their ground. Even though this is a car rental facility, the space is still maintained and at least owned and needs approval from the authorities at the airport. So they called us. I think we had 17 days from the time they called us to when their contract milestone was coming up. They had been introducing TRAXyL and FiberTRAX to the authorities for a couple of weeks because they had met us through a webinar or a trade show. They had heard about us somewhere. They were trying to get the approval. They called us. They said, "Can you do it?" And we came out. This was about 600 feet, and we did it in one night. We came out and surveyed it that afternoon or the day before, and then the next day we went out and we installed it using our machine. The facility could not shut down their operations. They process hundreds of thousands of cars a year. So they had their cars being returned, picked up, washed, serviced, maintained, parked all over this parking lot and these facilities, and they couldn't shut down the operations. So we were able to do half the run, cure it, and let everything happen. And then we paused the machine to let that happen, and then we ran the machine the rest of the way. So we did about 600 feet in one night. We did install a junction box in this area where you see the tree. There's a grassy median about 20 feet that we were able to install a junction box. The approving authority met us out there the day that we surveyed it. We told him what we were doing, and he had no problem with it. He appreciated it because we weren't cutting into their surface and where their utilities were. The only thing he had to do was do a quick utility locate in that grassy median area, and within 30 minutes he came and left, and we were off to work. So a really good use case for on-demand fiber in a very strict environment with a lot of paved surfaces, multiple transitions. We are funded partially by the National Science Foundation, where we received a grant to do a phase 1 grant to do a durability study on our FiberTRAX, where we put a bunch of different samples, into an environmental chamber. We put 4 different types, so we had a different cable in one, we had a different top coat, bond coat in another, and then we had a different varieties of those. So we actually have 4 different types of our FiberTRAX installation, and dozens of these samples in an environmental chamber. This wheel is simulating a residential environment it's basically the same as an F-150 weighted down with almost 1,500 pounds of pressure. And it was traversing across this asphalt, which was poured to residential standards here in Virginia. and cut, and the FiberTRAX was laid. You can see these cables that are coming down and out of the environmental chamber. It's being optically monitored and digitally monitored outside the chamber. We cycled the temperatures from about -30 up to 160 Fahrenheit, 0 to 100% humidity, introduced artificial misting to create icy and wet environments, hot and dry and cold environments. It was quite a show, and it ended up passing, this wheel ended up passing over these samples almost 700,000 times by the time we were done with this test. And we had failures on 3 of the family samples that we had put in there, which was great. That's exactly what we wanted to do. We were able to plot on a graph some data that told us when things would fail, different intervals. And so we were able to analyze some of the samples, understand why. We had one family sample that didn't fail at all. And we even went beyond what we were trying to do here and did a 5-day hot soak, and even put more pressure from the tire fixture on it. And it didn't fail. The optical sensing or the optical signal never failed. And we know that that's not we've always heard anything can work in a lab, and we completely understand that, but we were a little blown away because we were placing bets, and I completely lost the bet, thinking that the time interval that it would fail at, and this one didn't fail at all. And so we know that it has challenges sometimes in the real world that we don't experience here in the lab, but it gave us a lot of confidence in which technique we should go out and install with. So that's the technique that we're using today, the one that you saw in the cutaway a little earlier. And it gave us the confidence to go out and do the work that we're doing today. And so a little bit about where we started and where we are today is we actually started pre-2017, but it was more in the garage and less in the field, and little less traction here. But we do have multiple patents that are issued around the technology, multiple that are pending. We've been awarded with many awards, both locally and nationally, in the defense and in industry. One interesting one was a Satellite 2020. It was at the very beginning of COVID. About 6,000 people attended this conference in the DC area. Elon Musk was a keynote speaker. So a very big conference, and multiple, I think there was a dozen different startup companies pitching in this startup space competition, and they were from around the world. I think there were 7 different countries represented, and it was all about satellite. And it was interesting because we won, and we're not a satellite company, but the judges found it so critical for terrestrial on the ground infrastructure to be beefed up and more accessible than what it currently is, so that the satellites could then actually communicate down here and having robust infrastructure to do that with. So pretty cool for us there. We've also participated in different business programs, incubators, accelerators. We've been working with different municipalities, ISPs. We've gotten now 2 grants from the National Science Foundation, 2 contracts with the U.S. Air Force, 1 with the U.S. Army Corps of Engineers, for different R&D and contract work. I'm actually down in Vicksburg, Mississippi today with the Army Corps of Engineers. We've got a demonstration for them a little bit later as we're wrapping up that that contract. But we've just been very well received in the DoD and the commercial industry, because the connectivity challenges are the same no matter where you are. If there's a need to get connectivity, it's a challenging process. So a lot about internet connectivity and broadband, and it's even become quite exacerbated over the last 18 months because of COVID, because people have been moving to telehealth and virtual learning, remote work, teleworking, and there's just a lot of need for connectivity, and the digital divide is a real thing. I mean, we're in Gainesville, and a lot of you know that Ashburn and the Loudoun County area is kind of a hub for fiber and all things fiber and data centers. But on the other side of the county, there are places that don't have connectivity, or they're using cell cards and paying a lot of money to get connectivity. So just where I live, the digital divide is very real. And as you get more to the center of the country, the more divided it becomes. And so, we want to bring connectivity to a lot of people. There's a lot of different industries that can use it. One that I'll point out here that hasn't been talked about is optical sensing. And if you're not familiar with that, you can actually use a fiber cable and put different electronics on the end. So you're not really using it for broadband, but you're using it to sense the environment around you, where the fiber essentially kind of turns into a microphone where it can pick up the different vibrations around it. So if one of the demonstrations that we had done for us from an optical sensing company was they use buried fiber all the time, but they wanted to test out what our surface mounted fiber would look like. So they connected their electronics, they positioned somebody in a parking lot across the street, and they started driving towards our location, and they were able to tell, okay, they're in our parking lot now, and the vehicle's moving at about 15 miles an hour. They were able to tell us when it stopped. They could sense that the engine block had been turned off. People had gotten out of the car. They were now on foot walking around. They got back in their car, turned on the engine, and started driving towards us again. And they were able to tell us, all right, they're a few feet away from us now, but it looks like somebody stayed behind. One of the two pedestrians didn't get back in the vehicle. One of them still walking around the path behind them. So they were able to sense the difference between cars, vehicles. They've said that they can even sense the difference between a rabbit and a deer approaching a perimeter, because of the different cadence that you see with all these different noises and sounds and vibrations. And so it's being used a lot for data collection within a city for traffic control or monitoring the amount of traffic that's in a particular area. Bases and airports are using it to augment their existing security, where they've got perimeters that they can't patrol, either patrol by manpower, or cameras can't reach in that area. So they've got these areas of risk that they want to be able to control or monitor a little closer. So maybe they have an optical fiber that is on an area by a chain link fence. They can actually tell when somebody's breaching the fence using clippers or something like that. So just want to touch on that a little bit, because it goes to think about how many different use cases there are for fiber beyond just internet connectivity and streaming and everything else. So briefly, just a little bit about us. I kind of mentioned Dan. He's at the Vicksburg Army Corps site right now with our customer, and he's with our team. He's an engineer by trade and education. He also worked for the Intel community for 12 years, where he became an optical fiber expert. He did all things telecommunications and fiber related. He's the brainchild of the technology and so I've known him for many years. I'm a graduate from Radford University. I've got a business degree. Went into my professional career was 12 plus years in the construction environment, building environment. Did a lot of work at NIH, Walter Reed, helped construct the NPR building in DC. So worked with Johnson Controls and other companies for a long time, a lot with the new technologies and system integrations and digital controls. We've got a pretty good team behind us, a really good team of sales and project support. We've got engineers on our team, and then we're also supported by contractors who are helping design and build our equipment. And we've got a full legal and accounting and marketing team that are all outsourced. But we are looking to grow our team. We're looking to add new engineers and technical positions to our team. So if you know anybody who might be interested, quick plug for our needs there. And that's about it. I'm going to open it up for questions in just a minute. And but just wanted to throw out, one thing that this group, when Ashley asked me to present and gave me the opportunity to do that, I've been to the events before. I know that when we met, it was a few years ago, and so we were very early in what we're doing. Since then, we've continued to look for new pilots where we could do installations. We're looking for companies to partner with to distribute or to reach some of our customers. But another thing that was really intriguing is that we get questions all the time about paving and what could happen in different scenarios. And we have been limited on some of those resources, but we would really love to be able to have access to a parking lot where we could just run our equipment for a long time, where we could do different paving R&D and test different methods where we're paving over top of our fiber and just understanding what some of those could do. So if there's anybody out there who's listening that could potentially help on that regard, we would certainly appreciate the opportunity. And if anybody's interested, again, we're in Gainesville. We can schedule a demonstration of our FiberTRAX and our FiberTRAXsters. We're happy to do other presentations where we can show other video. And that's actually what I'm going to do right now. And happy to hear any questions while I bring those up. All right, I don't hear anything yet, so I'm going to start this. This is the Greenville, South Carolina. Ashley, let me know if you can't see my screen, but I think you can.
Yeah, we can see it.
Great. So this is our installation in Greenville, South Carolina, again, using our prototype machine that we built ourselves, where we're the fiber spooling off the cable. We're going across a drive aisle between curbs. And this is our first pass. Our new machine, by the way, it does do a single pass with both applications going down simultaneously. So you can see there where the fiber cable is laid and bonded, and it's cured with these lamps. So immediately when that leaves the back of the machine, it's walkable, drivable, it's protected. And then we come back behind it with a top coat to protect it a little bit more, blend it in, and it just adds different properties that we'd like to see from there. And so that final link looks like this, where it goes across the road. We come across to, we come up to a, yes.
Sorry, Stephen, maybe we can't see the screen that you're showing. It sounds like you just switched screens, but we're still looking at.
Were you still looking at the present? Let's see, I'm just gonna.
I thought we were looking at a title page.
Oh, I'm sorry. No, so were you able to see, let me do that again. So have you, is this the first time seeing this, or
Yes,
did you
please.
see this first?
Yes, please. Start
Okay,
over.
sorry about that, my mistake. So in this video, you can see the fiber being laid down in its first pass, where you've got the fiber and the bond coat adhering it to the surface. It's cured by these lamps, where immediately it's walkable and drivable. It's protected, and then we come back with a second pass and put it right on top. And this is with our first prototype, our current machine. Again, it does about 1,000 feet an hour, and it does these two processes that you'll see in a minute together. So we come up to a curb, and I'll show you how we transition through there. So here's the final product. It's black on asphalt, so it blends in nicely. And this is a fresh line. Once you get a bunch of cars driving over it, dirt and other debris, it blends in even better. But you can see in this location, we didn't come up the face of the curb. We actually drilled a hole at the base of it, and then it comes out in this expansion joint, and we ran FiberTRAX across the sidewalk into the grass behind it. So we're able to go through it. It's keeping the fiber protected at all times. It's not putting any sharp bends on it. And we're able to color match. So I know it's not an exact match, but it's the color the customer chose. And once again, once you get a lot of dirt and traffic over it, it starts to blend in well anyway. So you can see we come into a traditional hand hole. We actually run another hole here. So this is another transition method where we come in from the sidewalk into the soil, up into the junction box. And here is a splice enclosure, a standard off-the-shelf splice enclosure using standard off-the-shelf fiber and the conduit, the microduct here. And then you can see this area here where the contractor, the service provider trenched to a building using a conventional method. And we met in this handhole, they spliced, and that's exactly how we made the transition. So they were able to go to the apartment complex itself. And here's a finished product. So again, we did the same thing on this side. They ran a trench to the apartment building, and we met at a handhole on the other side of the curb. The last video I will show is, this is pretty fresh. This is our new machine that is doing two passes at the same time at our lab or at our facility. It's still a prototype. It's a production prototype where we are, it's beefed up quite a bit. We've still got a fiber spool on that runs down to these UV lights. It cures, and right behind it in the black box is that top coat. So as soon as it's as soon as it gets down under these lights, it's cured. It lays the top coat on top, and we're done. And that top coat will cure in about 20 or 30 minutes, depending on ambient and surface conditions. So the warmer it is, the faster it seems to cure. The colder it is, the longer it takes. But generally, it's minutes before it's fully cured. And we speed this up just a little bit, give you a view of the other side, and we're done. So I'm going to stop talking and I'm going to see if there are any questions or comments that I can address.
Thank you, Stephen, very much. And we do have a couple of questions in the chat box. The first one being, have you received any traction from the state of Virginia in their broadband initiative?
So that's a good question, because I had it listed as a logo, but I didn't address it. So just recently, as of last week, I think it was, the state of Virginia and some municipalities, and then CIT, the Center for Innovative Technologies, and several others came together to host the inaugural Virginia Smart City Challenge, where there were 50 plus companies that presented their technologies and how it could support smart cities, different IoT, and making communities safer, smarter, more efficient. And we were selected as one of 4 who received what they called their top prize. So we got some cash, we got some network support, we got some free office co-working space, but we got the one of the first 4 inaugural awards for that. We have also been working with many different municipalities, Fauquier, Prince William, a little bit of Alexandria, and other places where we've been able to communicate and educate them on what we're doing. We've talked to the Virginia DOT, and we've had installations approved on a case-by-case basis. But yeah, we'd be happy if there's any other connections within the state or general region. We would love to have any of those. Either we would be reconnecting with someone or meeting someone for the first time, and anyone in the space, in the sector that we could meet would be great. So yes, we've gotten some support. We're still growing, and we haven't met everybody that we'd like to. So yeah.
Thank you. And the next question is, what is the conversation with the broadband vendors in applying this to neighborhoods where they want to offer services?
So we've worked with a few different broadband vendors, and I'm thinking broadband vendors as ISPs, internet service providers. So if that's not the case, please let me know. And we're providing it currently on a service basis, where we're going out to do the installation like we did in Greenville with an ISP. But we'd really, more of the conversations recently have been, how can I get my hands on the machines? How can I get trained on it? We've got 2 machines right now that are built and being tested and in the field. One's for the U.S. Army Corps of Engineers, one's for the U.S. Air Force. And then we've got 3 more that are funded by the National Science Foundation to go to different commercial customers. One of them is an internet service provider, one of them is an infrastructure and cabling contractor, and another one is a general contractor who oversees larger fiber installation projects. And so those conversations have been going very well. They're excited to be a part of it. They are getting their hands on a machine. They're buying the protective coatings and the cable from us. We're training their crews on it, and they're excited to get it. And we will be getting a lot more feedback from them over the next 6 months as we go through this kind of pilot or soft launch phase of training others to do what we do. And so, but I mean, they're grateful in a way that they have another way of getting installations. They basically have said that there are projects that they've had to pass on that the end user couldn't go forward with because of the cost. And so that if they can bring down the cost and the time to do it, that it actually puts many more projects back on the table.
Makes sense, and thank you. Then we have 3 questions that can sort of be grouped into one. And they talk about the risk of damaging the painted line. So the first one is, what is the risk of vandalism? Like, can they just be cut with a blade? How do they hold up over the time as pavement degrades or begins to fail? And then also under vehicles and snow plows, how does it hold up?
Yeah, so that durability and some of those questions, snow plows is actually our #1 question that generally comes up even in the South, believe it or not. And I guess this ice storm in Texas recently brought it top of mind for people, but we get those questions all the time. And we like to think about it a lot like the road network, where the road is, there's multiple paths that go to the same spot, and the road gets potholes and the road needs to be repaved. And it's an asset that serves a very valuable purpose, where it transports people and to their endpoints. And we think about our FiberTRAX as kind of the same way. It lives on the road, and it acts like the road, where it takes value. It's a valuable asset. It takes information to different places, And when something happens to the road, it gets a pothole, it gets repaved. There might be a little outage where somebody goes in to repair it. But if you think about FiberTRAX, the beauty is that you can have it on both sides of the road. You can have it on two different roads that go to the same spot. And so you create a mesh network and redundancy that's built into it. So if you have something that happens to it, you can actually reroute data down a healthy link instantly where the end user doesn't see an outage. The contractor would get notified and go out and be able to make a repair. The FiberTRAX is, we say that you want to install it on a good area, not a gravel road. It's probably not the best place. And if you got a road that's completely beat up and it hasn't been serviced in 30 years, it's only going to be as good as the surface it's bonded to. And we want it to ultimately last as long as the surface it's bonded to. And so, we again want to put it in areas so there's a few different ways you engineer it so that you put it in an out of the way location. If you can't do that, then you can maintain it where you can just go back out and essentially put the stripe down. Once the fiber's down, the splices have happened, the junction boxes are there. You can extend the life of the line by just running a new top coat. And there are striping machines for that. There are ways to maintain it. And it's a lot like painting a line on the road. The lines get restriped every couple of years or even more frequently in a lot of cases. And so you can extend the life of that. If there is an outage or an interference for some reason, you can go in and make in situ repair where we've been able to chemically and mechanically remove the top coat and the bond coat, expose the fiber, put in a new piece of fiber there and do fusion splices and lay it back down and recoat it. We've been able to demonstrate one of those in about an hour once we've arrived on site. Moving at 1,000 feet an hour, you might just choose to run a new link. Take your service crew, go out to the site, take the machine, drive it between the junction boxes, and in a brief time, you're back up and running.
And the other aspect of that question that I don't think you touched on is like, could it be cut out of vandalism? Like, could someone just come up to this with a razor blade and cut through it?
Yeah, thank you for bringing that up. So we think about it as no more or less susceptible than other cables. You've got junction boxes that are on the side of a building that have cables that run up it all the time. If you look at many of the utility poles, there's cables that run up the utility poles. There's junction boxes that sit on the utility poles. We've all, in many communities and business parks, seen the green junction boxes and pedestals that are hidden behind bushes. They're all very accessible if people wanted to access them. So we don't really see it as more or less susceptible. It's very durable as far as any traffic. We've had buses, snow plows, we've had forklifts, construction vehicles run over the lines. If somebody wanted to vandalize it, just like any of those other cables or anything else, they could, do damage to it. We've had it out at a school for 3 or 4 years, and kids are probably the most notorious for doing things like that. They've never touched it, never even noticed that it's there. It's a line on the road and on the sidewalk that it blends in. You don't really notice it. So we haven't really had to deal with too many things like that.
You'll like this question.
Okay.
What
I like them
happened?
all.
Well, I think you'll especially like this one because I think it'll lead to a broader conversation. What happens during a mill and overlay asphalt maintenance project? Do all tracks get removed and replaced?
Yeah, so that is something that we'd like to test, having it down and seeing how the mill and relay occurs. There are areas that if you've got I think they're the road aprons, the sidewalk aprons, that area that is still concrete that leads right up to the road, and that part doesn't generally see a mill and overlay. But and if you lay it on that area, then don't think it would happen. But yes, if a mill and overlay is happening where FiberTRAX is and the road is coming up, then yes, this is coming up too. And that's where building the network either in advance of that, when it's first built, so you have redundancy on different roads that create a mesh network, or that's a planned event, and so you're checking with all the other utilities. You're calling for 811 or 411, whatever the call first number is, and you're planning that. And so you have to plan for everything else too. And so the idea is that you come out and that a line's going to come up with the remill process. So run a new link in advance and get your customers up on a redundant network before that interference happens. and then you could lay it back down. And we actually want to create that process where a new road is getting laid and a new paint is getting laid and new FiberTRAX is getting laid. And it just becomes as standard as the reflectors or paint lines on a road.
You might be also happy to know that the director of 811 is on this call.
Well, I got it right with the first number. I said 811,
Yes,
not
you did.
411.
And feel free to make that ask again. I'd like to reiterate what Stephen said to the people on the call is they're looking for a parking lot or something similar, right? To test the milling portion of this, right?
Well, so we want a parking lot where we can run thousands of feet of FiberTRAX, just like a kind of like a test bed for us, where we get a new machine, we get a new technique. Right now, it's we've got some customers who, early adopters that are open to letting us try different things, but they aren't always interested in having these stripes all over their parking lot. So we actually had to drive to Atlanta recently to do this, where we ran a couple thousand feet on a parking lot. If we had something more local, that would be excellent. We would also like to try that repaving, the milling process. One thing that we think is when there's just a new top coat of asphalt being laid on an existing road, and it's not actually churning up the asphalt and recollecting it, but it's just repaying asphalt on top of asphalt. We think that it would provide a really good protection layer for our FiberTRAX, and that FiberTRAX would just be sandwiched in between. And we would just like to try that method out and a few other techniques that we have. So thank you for bringing that up again.
Yeah. And hopefully if anybody on this call would like Stephen's information and to provide access to a place where they can do that testing, definitely reach out to me and I'll connect you guys. We have another question in the chat box relating to the milling question. What is done or can be done to protect the FiberTRAX when an excavator is digging in the roadway? How would an excavator know that this exists?
So we do want to get into the standards and as-built procedures that any other infrastructure contractor is doing or cabling contractor is doing. So we want 811 to be informed of what we're doing. So if someone gets they get a call, they call into 811, they get notification that there are utilities, and we want to get marked in the same way. And we want to educate the industry enough that they know what it is when they see it. And maybe there's ways to do that. We do have a steel wrap cable, so there are ways to tone the line and ring the line to find out where it is and things like that. So by as-built, by being a process within the 811 procedures, and then also we know that mistakes are going to happen. We know that accidents are going to happen. Things are going to get cut. Just so I'll give a quick story about the Greenville application again, where we did an install for that apartment community. They called us up, I don't know, maybe 3 months ago, and they said, hey, just want to let you know, everything's going really well down there. But ironically enough, we've had a power interruption, which took down our internet, and we had a buried cable that was dug up and cut and severed by a backhoe that was cutting into the ground for something else, for landscaping, I think. He said it took down our line. So he goes, I know that you guys are doing a new technique. It's a pilot and everything, but you've outlasted power outages and traditional cables so far. So we know that at some point something's going to happen to us, and that there's going to have to be preventative and emergency response maintenance. And again, having it on two sides of the road, having that redundancy and mesh network built in, you can do it so much quicker now. And so if you can do it on both sides of the road, if you can do it on two roads that lead to the same end user, those are ways that you can mitigate that risk. But I mean, there's no one who's going to stop a saw or a trench going into the ground, or even errant snow plows take up curbs and buildings and cars and different damage on the road all the time. So there is a maintenance process to it, just like anything else that's outdoors.
And as you talk about the mesh network, the projects that you've done, have you all been contracted to create that mesh network from the jump? Like, are you putting down multiple lines in multiple places to serve that each time?
Yeah, good question. So in many cases, yes. So at the school, one of the installations that we did was there was a fuel island where their municipal vehicles, buses, ambulances, police cars go through and they fuel their vehicles. and they wanted to monitor that on their county network. So they ran the communication link from the fuel island back to the school. And so we used FiberTRAX for that. We ran it on the north side of the parking lot and the south side of the parking lot. Ultimately, both of them ended up at the school. Another one that we did was for that Greenville apartment complex. We ran 4 links across that parking lot so that it could, and it was on the, if you think about it, the parking lot is shaped like a clock, a circle, and you've got the north, the south, the east, and the west, where we ran a link across it to tie into their network. So if any one of those links go down, they have multiple other paths that lead to the same network. And then also the DOT bridge that we did for a general contractor in Ohio. They were servicing an AT&T cell tower. They're servicing a new community, and they're servicing the municipality. So 3 different customers on that FiberTRAX link, or those links. That's where we put 96 fibers down. We put it on the north side and the south side so that they have redundancy if anything happens there as well.
Makes sense. Before we close out, are there any other questions? Anyone's free to chime in or put anything in the chat box. Maybe not.
I'll leave
Steven?
one kind of teaser thing if I can, to say that we've been talking a lot about FiberTRAX, but there are new and cool techniques that we're doing where we're looking to put hybrid cables together and under our FiberTRAX link. So one of the developments with the Air Force is where we're actually running conductors and fibers in the same cable so that you can get low voltage power, power over Ethernet, and fiber to the same location to put up different towers or security cameras. We've been talking to the Washington Metro Area Transit Authority about getting security cameras and phones to different areas of their parking lots for their patrons to use. So that's something that we're thinking about. And we're also thinking about a hollow conduit or tube where you could insert your own cable or even use different gases or fluids that might flow down it. So not something we're currently doing, but something to look forward to. And those are both development efforts with the Air Force.
Excellent. Good to know. Well, since you can't see the chat box, I do want to tell you, you're getting compliments like awesome product and idea. Thank you for sharing. Great presentation. Thank you. And very impressive idea. So
great. Thank you very much. Really appreciated this. This was a great platform, a group that we met years ago, as you know, and we're impressed with the group and the members. So we definitely appreciate being reconnected and hope that we can stay more connected through this year.
Absolutely. Well, thank you, Stephen, very much for your time, and we'll let you go get to work in Mississippi and have a great rest of your day. Thank you all for being here.
Thank you again.